Hello. It might not be the most appropriate thing to start with. On a testing and quality rating conference, but I'll assume you can all hear me now. Great. So my name is Erik Tiits and I'm the partnership manager at Nordic Testing Days. Today I will moderate the Trafo room and where we have 2 tracks. And I'm very glad to welcome you all here. At the Trafo room, as Kasper and Harles were joking around, is a nice reminder of the last venue we had the physical event in 2019. So great memories. If you are suffering still with low quality on video, then you should have the link for slides in the Q&A section, or you should have them shortly there at least. Okay, but moving on from the tracks, first up we have Jorge Marín. He's an engineer with diverse background from different areas, now tech lead and advanced QA engineer at OutSystems. Hello, Jorge. Hello, in what country you are at the moment?
I'm living in Spain at the moment.
Okay, great. So it feels like an Eurovision Song Contest at the moment. But Jorge will talk us about contract testing and how this should avoid nasty bugs appearing in production regarding your microservices. So Jorge, the screen is yours.
Thank you. Hello, everybody. Good morning. Good afternoon. How are you? I hope it's a beautiful day in Tallinn. But well, here it's not that good. Anyways, thanks for coming to my talk. I hope you're having a splendid day already. And the rest of the day is looking awesome with so many more interesting talks. And I really wish you learn something today and enjoy this specific talk. So, what are we here for? We're going to talk about contract testing for microservices, a humble introduction. My name is Jorge and I'm an engineer. Details about my past doesn't matter right now, but I work as a tech lead for our system at the moment. And if it rings a bell, we are hiring, get in contact with me. Now, it is crazy how things have changed lately. Usually I take a deep breath before speaking in front of a large audience, but right now I'm talking to the screen, so it's not that bad. In any case, it's going to be fun, so Alonso. First of all, I want to stimulate your brains with a couple of terms to warm it up. Unfortunately, I cannot interact with you as much as I would like, but I will let these words sit in your heads for a minute, right? So we have unit tests. I really hope that every one of you know what unit tests are and are used to them. Then we have the cloud. Some of you might be working in the cloud. Some of you might be working on-prem. Web APIs, maybe you have a service for adding products to a cart or to perform a transaction in a bank or something similar. Microservices, the microservice architecture, where you have several services, several small services or programs talking to each other. End-to-end tests. Some of you might know this or might have been running them for some time now, or maybe you are starting with them. I'm aware that there's several talks in this very conference about end-to-end tests too, so make sure to check them out. gRPC, fair enough. Event-driven topologies or services. Production. This is a famous word in testing conferences. And we have burrito de carne, but that was just a joke. Let's just move on, okay? So, history time. Long time ago, in a galaxy far away, software, right? The very first time a stored program computer held a piece of software in electronic memory and executed it successfully was on the 21st of June, 1948 at the University of Manchester. It was a program written by Tom Kilburn and calculated the highest factor of the integer 2 to the 18. Gladly, everything went according to plan, no bugs. But even so, the concept of bugs we know nowadays already existed. 1 year before, in 1947, Grace Hopper described a malfunction in the computer Mark II caused by a bug, a moth. And we all know that story, right? So what I mean with this is that every time you build something, there's a chance you get something wrong. It could not be relevant to the normal function of what you're building. Let's say you mistakenly add 3 more guindillas to your soup. Annoying, yes. Critical, well, it depends if you like it spicy or not. But these little mistakes can lead us to disasters like the explosion of the Ariane 5 or the recent accidents with the Boeing 737 MAX. So naturally, we all want to test all the things, right? At this moment, we are going to be focused on functional testing. So this means validating the software system against the functional requirements of a specification. There are other types of testing that you could perform, like performance testing, load testing, etc. But in this presentation, we're going to be focused on the functional testing part. I would bet most of you are already aware of the testing pyramid, or the testing pyramid. The testing pyramid, this testing pyramid. No. Anyways, let's just focus on one testing pyramid for now, okay? So this one, for example. So when you are writing software, usually the first thing you want to check is that the function that you write behave in the way you expect. So you're given some input, they give you some output, and that's the expected output, and that's the expected behavior. We test that behavior using what we call unit tests. Then it starts getting complicated because a service is not made out of one function. Well, some services now with serverless might be done with one function, but usually services are a bunch of functions working together, right? And these functions will call each other and will pass this around, and you need to test that also. How you test that? Well, you could test the service as a whole. So all the functions together, if you give them some input, you should get an output too. So you could treat the whole service or the whole application as a black box and then test it as a black box. But then again, you might have a system, there's more. You might have a system where you have several services talking to each other. And now you want to test the system as a whole. You don't want to focus on the individual services, but to test how the services talk to each other and to make sure that the system produces the outputs expected to your inputs. So this is what we could call an end-to-end test, where it involves all the programs and all the services and all the applications within your system. So we treat the system as a black box. Now, with that, one might say we should be pretty well covered by now, right? We've been building confidence on the smallest untested piece of code, which is a function, to seeing the whole system in action working together, and we verify that the system produces the outputs we expect given some inputs. But there is a subtle catch here, and I'm going to explain it now. When you're testing the functions within your service, most probably you are the one making use of them, right? Your service does know which functions to call and how to call them. If you have a problem, if you design a function wrongly, it will fail, and you will notice. You'll execute it locally, and the program will fail, or you run an input and it doesn't give you what you expect. That's regarding the functions. But the systems are much more complex. And instead of functions, as I said, you have services, and also you have services talking to other services, right? And these services can be owned by different teams. So how can we ensure that not only our service is functional, so given an input to our service, it gives the expected output, but also it looks functional to the eyes of the other services. It's look functional to the eyes of other teams. That's the hard task here. So maybe, and just maybe, you could make use of mocks. So these yellow boxes here could be mocks, essentially pieces of software that don't implement the full logic and just have a predefined behavior as black boxes. So for this input, you give me this output. I don't have to calculate anything. You can build this mock, you can design them, deploy them, or put them next to your testing set, next to your service that you are testing at the moment. And then write some quick unit tests in each side of the services. This guarantees isolation, so you don't have to test service A and service B at the same time because you have the mocks. But when you write the mocks, you make assumptions that might not be valid, and it's also hard to keep both sides in sync. So once you write the mock, it works the first time, but once service B is updated, you need to remember to update the mock on service A, the mock that service A talks to, and etc. So it's kind of hard, and we need something that captures everything and updates everything as well at the same time as you are updating your services. So how do we do that? Contracts to the rescue. So in a contract, we have two parties agreeing on how to do things, right? This is what the definition of contract. But didn't we say that the main three levels of functional testing, saying unit testing, integration, or service level tests and end-to-end tests, are more than enough to verify if a system is behaving properly and working properly, working as expected? Because we just said that we have a system, we don't care about what's inside, given some inputs, it gives some outputs, right? That should be enough. Well, let me tell you, well, probably most of you are already aware, but working with end-to-end tests is not that simple because you need to spin all the services. You need to deploy them together for them to talk to each other, and you need to take care about deploying the microservices, the network, deploying the databases with the right data, the email server, or any other kind of supplementary server you might need. It has a huge cost to write and to maintain these end-to-end tests. Sometimes they are non-deterministic because of the network. It takes a long time to run, and it's difficult to achieve full coverage because you have many services and many use cases, and you cannot cover everything, right? And also, depending on how you implement these end-to-end tests, you might need to spin up new environments in a cloud or in a machine, and then different services have different way of being deployed. You need to check with each team how you deploy each service, which are the dependencies. It's chaos. It's a chaos, and I can tell you for sure. So this is actual footage of myself or a coworker trying to coordinate the end-to-end test at my previous company. So it's hard, and I can tell you. So getting back to contracts, maybe this is the solution to it. So what a contract is, a contract asserts that the inter-application messages conform to a shared understanding that is documented in a contract. So both consumer and provider agree on a contract, agree on a specific set of rules and behaviors, and that's the contract. And contract tests just make sure that that behavior is happening, and it will fail in case a contract is not met. So when to use this kind of contract testing? Well, it's immediately applicable anywhere where you have two services running that need to communicate to each other, such as an API client with a web server with a front end, or an API client to just another API client, a backend, event-driven. Anywhere where you have two services or two entities talking to each other, you might have a contract, right? This contract testing especially shines when you have a microservice architecture with a lot of services talking to each other. And also a little bit of terminology. In the picture on the slides, you can see the consumer, the provider, and the contract. So the provider is the one providing the APIs, providing the services, providing the endpoints, so providing the logic itself. And the consumer is the one making use of those functions. So the contract is above them, and it's an agreement between the consumer and the provider on how things behave, how things work, and how the communication should go from one service to another. We also have different kinds of contract testing. I'm not going to delve into it that much, but just to mention them, we have consumer-driven contract testing and provider-driven contract testing. Some advantages to contract testing is that you focus on testing the interface itself without dependent applications running at the same time. So you just only care about your service and the contract itself. You don't have to deploy anything else on the side. You won't be testing the connectivity between the two systems. You want to make sure that the other service is functional to your eyes. So what you expect, what you send them, you expect them to behave in a certain way. It doesn't replace any other functional test, so you still need these unit tests, service level tests, or end-to-end tests, but it is very effective at ensuring that if a change is made to any of the ends, if a change is made to the consumer or a change is made to the provider, and that breaks the contract, one test will fail. And if one test will fail, you are pretty sure that you cannot deploy that consumer, that version of the consumer and that version of the contract, of that version of the provider at the same time, because they basically won't work because the contract is broken, right? And because of that, as I mentioned, you don't have any live integration between the services, so you can test in isolation. You can run this contract testing in your pipeline and it won't block anyone, it won't block other teams. You don't have to deploy additional services or deploy additional infrastructure, networking, anything. You just test this next to you, like if you were testing locally. So it's quite convenient. Now, if we talk about a little bit about how these consumer-driven contracts work, this is the before, but now I'm going to outline the steps. So basically, the first thing that happens is that the consumer writes some unit test against the mock of the provider. So the two lines in the middle of the diagrams are the mocks. So we still keep the mocks, but now on top of the mocks, we have the contract. So the consumer starts writing some unit tests against the mock of the provider, like saying, okay, if I want to do something on the provider, I send this, expect this back. That's a unit test. And those unit tests get recorded. They get recorded into a contract where you say, if I send this, I expect this back. If I send this to this specific endpoint, or this message to this specific queue, I expect this to happen and to return to me. So that's recorded into a contract. The contract is then put in a shared space so that the provider can have access to it. And then the provider, the requests of the contract are replayed against the provider API and verified against the consumer expectations. That means that all the contract that has been recorded, it gets replayed on top of the provider, now using the code of the provider to make sure that the provider is actually behaving as the contract is expecting. And yeah, the provider used then the mock for the consumer to replay those, to replay that contract and to test everything, to test the contract in isolation. So this is more or less how the workflow goes for contract-based, for consumer-driven contract testing. Now, benefits for this consumer-driven contract testing is that you focus on the needs of the consumer. It's the consumer that drives the contract. As you may have noticed, we started with the consumer writing the unit test. So it's the consumer deciding, okay, I want to make this call or send this message or whatever. Everything is driven by the consumer, right? It's a good mechanism to know when you have broken any consumer, because all the consumers will set their expectations, and then if your program of your service doesn't behave according to those expectations, the contract will be broken, and then you'll know which kind of contract or who consumer you broke the contract with. But this also have its own disadvantages, this type of contract testing. Imagine you have a lot of consumers, each of them will try to enforce their agenda on you, which on you as a provider, and therefore you might end up with maybe with a lot of endpoints doing the same or returning the same data structure or the same information, and it might be a little bit chaotic also. Also, if the consumer does not really understand the complexity of the things that you are doing, they might be requesting you to do or to return some specific data structure that for the that for the provider is actually pretty hard to build. So there should be some kind of balance between writing this contract only from the consumer side, not involving the provider in any decision. And last but not least, some people, everyone basically, if you are the provider and suddenly you don't change your code, but this contract testing start to break and they prevent you from deploying your service, but you haven't made any changes, is the consumer who made changes, they broke the contract, but because the contract is also executed on your side, it's blocking you from deploying your service because you are breaking the contract, right? So people might ask themselves, why, if it's not part of my code, why should it prevent me from deploying or from building additional features on the provider if who broke the contract was the consumer? I didn't do anything. I'm just implementing what the consumer told me to. And that's where the producer-driven contracts type of contract testing gets introduced. I'm not gonna delve much into it because it's not that. I don't have much experience with this kind of contracts, and it's not as popular as the consumer-driven contracts. But just to say a couple of things about it, is that it's definitely achievable. It's basically the same as the consumer-driven contracts in reverse. So you reverse the direction, you start with the unit test on the provider, and then you publish the recorded session or the contract to somewhere a common place between the consumer and the provider, and then the consumer downloads that contract and use the mocks of the provider to test their assumptions. Moving on, the implementation. So all these concepts are pretty cool, but now we need to implement them, and for that we have Pact. Pact, it's a code first, or it's auto-denominated as a code first tool for testing HTTP and message integrations using contract test. You have the website up there, pact.io or docspact.io. It's also family of frameworks that provide support for executing this kind of consumer-driven contract testing. You can see that there are libraries for Node.js, there are libraries for .NET, for Golang, Python, Ruby, PHP, C++. So most of the famous languages and most used languages out there. And this library will help us to write and execute this kind of contract testing. Going back again to remind how this consumer-driven contract testing work, it starts on the consumer, then the consumer runs the unit test, it generates a packed file or a contract file, it uploads the contract to a broker, which is the common thing between the consumer and the producer, and the broker will store this kind of contracts for each version of the consumer and the producer. The producer will then download that contract, run the unit test, and replay that contract, and then upload the results to the pack broker. And then is the broker the one telling you if the services can work together, or if you can deploy the new version of the producer, or it's giving you more information about it. Now, the type of applications with contracts that you can implement this contract testing could be REST and JSON via HTTPS, or a web service talking to a front end or a web application, or a web service talking to a web service, backend to backend, backend to front end, anything that requires a contract, right? You can also apply this kind of contracts to event-driven or event-based services using RPC or using gRPC, which is the specific implementation, and event-driven architectures with queues. So it's mostly applicable, as I said, everywhere where you have two services that need to talk to each other. Now, I just talk a bit about about how to implement them, but now how do you integrate this into your pipeline? So the first thing we have to implement this is a pack broker. The pack broker is basically the thing in the middle between the consumer and the producer, and it's an application for sharing the consumer-driven contracts and verify the results. It is optimized for use with packs and contracts, but any kind of other contract that can be serialized to JSON can be also be pushed to the pack broker. And the good thing, this is a screenshot of one of the pack brokers out there, and it solves the problem of how to share the contracts between the consumer and the producer. It tells you also which versions of the applications can be deployed together safely. Automatically version your contract, saying this is contract version 1, this was generated on the 21st of June or whatever. And it also allows you to visualize the relationship between your services to see which service is talking to which service through which contract. It provides several stuff like a RESTful API for publishing, retrieving packs, auto-generated documentation for each pack, dynamically generated network diagrams, provides most web hooks, so you can hook to GitHub Actions, to Jenkins, or anything. You can also view the diff of different contracts, what changed, and it has also a command line utility that you can use. So it's actually quite useful. But there are some other ways of integrating this contract testing in your pipeline. So you might have the consumer CI view committing the contract to the provider code base, and then the provider code base will use that contracts in the that it has on the code and the repository to run the unit test. You could also publish the contracts to a CI view artifact, use GitHub Bitbucket to store them, or even you can publish to a random S3 URL, and then your consumer will download from that S3 URL and try to execute the contract. So there are ways of making this contract work. The main concept is that you build the contract, and that contract should be shared between the consumer and the producer. So this was my contract to you. As I defined in the talk description, we were going to learn what contract testing is. We were going to learn also how contract testing could be helpful and how it complements all the type of testing as the service level test and the end-to-end test and the unit test too. And also learn a bit of how to get started with contract testing. I would pretty much have loved to have a demo here so I can show you around how to execute the command line utilities and how can you prevent deploying one service if the other service is breaking the contract and stuff like that. But this presentation is also a little bit too short for the demo. So if you really want to dig into this and go to advanced tutorials, there's a lot of tutorials on YouTube and several also articles in pack.io website that you can go and check out. So here's some links. So you have the pack.io. I'll be sharing the slides after this presentation and also be available at the Nordic Testing Days official website. Some articles and some YouTube videos for you to dig deeper onto this topic. Next year, I intend to be here again, hopefully talking to many of you for the second time on how you implement contract testing and the major pain points it raised during your pipeline integration. I want to hear success and failure stories during the next few months so we can work them out together and have a great extended section next year focused on the implementation itself, and this time with real demos in real life. And so please reach me out whenever you start implementing this kind of contract testing, and we can have a healthy discussions around them. I also noticed there's some other talks around consumer-driven contract testing in this very conference, so make sure to check it out. Now, again, thanks to the organizer and the generous sponsor for Nordic Testing Days for 2021, and I hope to see you next year in person. Now for the Q&A session, you can use the comment section to put your question, and I'll try to answer them. Thank you.
Hi. So yeah, it's me again. So we do have some questions, and first of all, thanks for the great presentation. I personally found it very interesting, having been involved with contracts in programming some time ago. Quite similar concept. I mean, what contract is eventually is pretty basic. But yeah, it's an interesting approach. But moving on to the questions, there is someone asking that this idea sounds very much consumer-driven. But what if we are in an event-driven architecture where I as a consumer don't call APIs, but I consume events from an event bus like Kafka or some other streaming service? How do I test that the payload produced is right? Does contract testing also help here?
Right. So I haven't done any real world scenarios with event-driven architectures using contract testing. I mostly have used web APIs and APIs with HTTP and JSONs. But it's definitely possible to do it. There are many tutorials online on how to do it. Even in the pack.io website, it tells you how you could make use of those frameworks, the JavaScript framework or the Golang framework, to spin up this kind of contract. So it's just a matter of using the libraries that are out there that are pretty helpful and are very well documented. And you tell those libraries which kind of API or which kind of architecture you have and where this service, the other service is listening to, and where the mock is and everything. And it will set everything for you. That live set the mock for you, will set the expectations for you, even if it's event driven, if it's messages on the queue, it will create the queues internally. It will do everything for you so that you are abstracted from it. You just have a contract and you care about the contract. So it's actually quite useful. And again, there's a lot of documentation in the pack.io website. You could go there and check it out if you're interested in this kind of advanced setup.
Okay, great, thanks. So yeah, I also was thinking during your presentation that you mentioned the bots, that it's a very, at least on the consumer-driven part, that it's relies heavily on consumer part. So just thinking if there is a problem that you have many consumers, so are there cases where you as a provider share your contract and consumers will have to apply with that? So, but that's probably the producer-driven contract part that you
Exactly,
discussed a bit
the
less.
producer or provide.
Okay.
Yes, exactly. It's a producer or provider-driven contracts, and it's this. As I said, it's the same concept, but just applied in reverse. So it's a little less, let's say, interesting, because when you build a service, you are interested in, you're building the service for all the service to consume. You don't build the service for yourself. Therefore, it's in interest of everyone that you design the service based on the specification and the expectations of the consumer, not on your own expectation. So that's why this contract testing is mostly focused on consumer-driven contract testing, where the consumer says, I need this and I need this, please make it happen. And then the producer will need to make it happen. But obviously it has its downside. When you are implementing a service, you cannot just go to other teams in your company and say, hey, what do you want us to implement? I'll do whatever you say, because there are constraints. It might be difficult. Maybe the API doesn't work that way, or whatever. So you need to reach a kind of a balance, between being consumer driven and producer driven, provider driven.
Okay. Great. So I see that several people have liked your slides as well in the Q&A area, where we already shared the link for those. So that's good. And I don't think we have any further questions at this point. So I think we can wrap up this session at this point and join in this Trafo room in 7 minutes, 10 minutes past 11, then in Estonian time. So and thanks again, Jorge, for your interesting introduction. And please, if anyone finds that interesting and would like to revisit the slides, then these will be available, and you can, as Jorge mentioned, learn more from different tutorials, or maybe even contact Jorge. And there is a high chance to meet him next year. So meanwhile, spending those couple of minutes now as a partnership guy, it's a must that I would kindly invite you to also visit the expo area, where we have different partners listed, and there is some content and also price draw in case of one partner, for example. So go check it out, and let's meet again here in 6 minutes now. Thank you.